Today we're going to be talking about divisibility rules. Now, divisibility rules are just simply some shortcuts that will enable you to be able to do some long division and to know what numbers go into a larger number. It'll make it a lot easier for you. So we're going to discuss some divisibility rules specifically for 2, 3, 4, 5, 6, 9, and 10. Again, these are just like little shortcuts that will help you be able to know whether or not a number is divisible by each of these numbers. A number is divisible by 2 if the number is an even number. So let's look at an example. If we take the number 24, that is an even number, so is it divisible by 2? Yes. Let's suppose we take the number 21. 21 is an odd number, so it would not be divisible by 2. That would be a no. What about for the number 3? For the number 3, the rule is if the sum of the digits is divisible by 3. So let's take a large number. Let's say you have 369, and you want to know, will 3 go into 369 evenly or not? All you have to do, the shortcut method, is to take 3 plus 6 plus 9. When you add those up, you get 18. Will 18 be divided by 3 evenly? Divided by 3? Yes, it does. So, is 369 divisible by 3? Yes, it is. It's a very short method to help you be able to do that very quickly. Let's take the number 56. Let's add 5 plus 6. So that gives me 11. So 5 plus 6 is 11. 11 does not go divided by 3 evenly. So this is not divisible by 3. So 56 is not divisible by 3. What about the number 4? The digit 4, the rule for if a number is divisible by 4 is if the last two digits are divisible by 4. So let's look at a large number. Let's say we have 6,832. All you need to do is look at that 32. Is 32 divisible by 4? Yes. And so therefore, 6,832 is also divisible by 4. What if we add the number 321 and look at the last two digits? Is 21 divisible by 4? No, it is not. So therefore, 321 is not divisible by 4 because it does not go into it evenly. All right, the number 5. You probably already know the rule for 5. It's if the number ends in a 0 or a 5. So we just look at the number 25. It ends in a 5. Oh yes, it's divisible by 5. What about the number 32? No, it ends in a 2, not a 0 or a 5. So it's a no. And then the number 40. It ends in a 0. So yes, it is divisible by 5. All right, the next set of numbers that we're going to discuss the rules for are the number 6 and the number 9. For the number 6, it has to be divisible by both 2 and 3. So let's look at the number 123. Well, remember, to be divisible by 2, it has to be even. Since this is odd, we know it is not divisible by 2, so it is not divisible by 6 because it's not going to be divisible by 2 and 3. What if we look at the number 348? Well, it is divisible by 2. Has that going for it? The rule for 3, remember, is you have to add them up. So let's go 3 plus 4 plus 8. That gives me 15. 15 is divisible by 3, so that works. So yes, it is divisible by 6 because it works for 2 and 3. All right. Now, to see if the shortcut for if it's divisible by 9, this is the same rule as if it's divisible by 3. So you've already know this rule. So you just simply look and see if you add up the digits, just like we did for the number 3. So let's do, say, 427. So we'll take 4 plus 2 plus 7. That gives us 13. That's not divisible by 3. So therefore, this is a no. Okay? It is not divisible by 9 evenly. And so that just tells you that it will not go into it evenly. We have one last shortcut rule to talk about, and this is the easy one. This is if it's divisible by 10. We know it has to end in a 0. So easy. We look at 53. Does not end in a 0, so it's not divisible by 10. If we take the number 50, it does end in a 0, so yes, it is divisible by 10. Again, these are just some shortcuts to help you when you're doing your long division to know whether or not these numbers will go into a larger number evenly without any remainders. I hope that information has helped you today. If you'd like more information about other middle school math classes, units, or lessons that I have available, or if you'd like some tutoring help, please just send an email to stemtutorplace@gmail.com. stemtutorplace@gmail.com. Thanks again, and I look forward to seeing you again next time or hearing from you via email. Thanks so much.